And speaking of GLS decomposition, there is something left, right? There is this L matrix left. You can project onto the L part. Now, that is not going to be as simple as projection onto one matrix, because projection onto one matrix results in one number. And L is about two-dimensional deformation. Right? There are two matrices with behavior like liquid. So you have to project on both and add them up. And the result is a matrix again. But you still have this statement that integral of this projection onto the plane, two-dimensional plane in that four-dimensional space of matrices, of the derivative equals integral over the boundary of projection onto L of this product. Now, what is this saying? And what is it giving to you, actually? Well, the result here on the left, and what is it that you are integrating, actually? Well, you are integrating the tendency to deform, right? When you project onto L part, you forget about rotation, you forget about uniform expansion, you only focus on how your material inside tends to deform by shrinking along one direction, expanding along the other with the same rate. Right? So you look at this kind of deformation that makes, for example, a circle deformed into an ellipse. And then you keep adding this kind of effects at all the points. And the result on the left is an addition of all that, which results in overall deformation of the whole object. And the claim is that you can compute that by measuring something on the boundary. And the result is going to be an overall matrix of that deformation. Or let's call it some L matrix of that deformation. What kind of information is there in this matrix? Well, this matrix has those eigenvectors and eigenvalues. Right? So you can take this matrix and you can find the eigendirections, and you can find the eigenvalues, lambda and minus lambda, for that matrix. And what you can say here is that this region overall, as one body, is now deformed, roughly speaking, expanding along this direction with the rate lambda, shrinking along this direction with the rate minus lambda. So that's what happens to the whole region overall. Well, what happens actually inside, if you go into those details, might be quite different. But when you add up all those effects, this is what you result with. So that's, well, I think it's quite physical application of the fundamental theorem, which is not one-dimensional, which is not numerical, like either of these two. So that's why people usually don't go into that. But I think it's good for you to know existence and the meaning of that.